Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to talk about how to use technology with the graphs of trigonometric functions. You should not really use technology to graph trig functions. However, there are many times within your homework or within a textbook that you're using that it says use a calculator, or it has a little calculator symbol next to the problem itself. So this is very common. You'll see a little calculator symbol right here, buttons and stuff like that. And if that's the case, it means you got to use a calculator here to do this problem. So this problem is very unique to a pre-calculus course. It's usually not in a trig course. That's why I don't have my little warning that that this is, well, I did have the warning, but I still didn't have any other conversation about it at the beginning. This is a good pre-calculus level example. Not much to it though. We're going to use technology to go ahead and graph this and find the maximum and minimum values of the function. So we're at Desmos right now, and we're going to graph, I'm going to graph it as f of x. That way I might be able to evaluate if I need to. It was the cosine of x divided by 2 plus the sine of x. And again, this is just something I mentioned in a previous video, but if you're going to graph in radians. Make sure you're in radian mode. This is going to be the default in Desmos, so we are already in radian mode. If you try to graph this in degree mode, it would look like a line, because degrees, you have a length of 360 before you have a full cycle. That's why radian mode is much better. So radian mode, and you can see there are an infinite number of maximums and minimums for this function, right? It goes on forever. So we want to find a pattern. So let's look at the maximums here, and notice that all I have to do is click, right? I have a maximum at 11 pi over 6, and then another one at 23 pi over 6, and another one at 35 pi over 6. The question is, how far apart are those? Well, if you look, the distance between 23 pi over 6 and 11 pi over 6 is, what is that, 12 pi over 6? So that's 2 pi. That's a distance of 2 pi. So I'm going to go ahead and state that the maximums occur, and I'm just writing this down below on my screen really quickly. They occur at 11 pi over 6, and then any multiple of 2 pi thereafter. And that's going to be, I'll show you the notation in a moment, but I want to finish on this screen first. The minimums occur at 7 pi over 6, 19 pi over 6, 31 pi over 6, obviously in the other direction too, right? Negative 5 pi over 6 and so on and so forth. And these are all 2 pi away from each other. So again, the minimums occur at 7 pi over 6 and then plus 2 pi k. And as I've written here, that's exactly what we stated earlier, right? The maximums occur at 11 pi over 6 plus any rotation of 2 pi thereafter. And that k in z means k is in the integers. So it's 2 pi times 1, or 2 pi times 2, or 2 pi times 0, or 2 pi times negative 1. So any integer multiple of 2 pi thereafter. Same thing for the minimums. They occurred at 7 pi over 6 plus any rotation of 2 pi thereafter. So that's how you would do that. Usually technology problems are not so terrible because they go kind of quickly. The other technology problem here that I have, and even though this is not a review video, it's somewhat short because with technology, there's just not much you can do. Use Desmos to find all solutions of the equation that lie in the interval pi to 2 pi. And then we're given this equation, secant of x is equal to 5. Now I'm just going to draw out how we're going to do this. So we'll have a secant curve. Whoops, that's not how you draw that. You'll have some type of secant curve. It might look like this, it might look like that, whatever. And what we're going to do is draw the line y equals 5. And we want to know, when do those curves intersect? That's really what we're going to do. So let's go ahead and see how that works. So here's the secant function right here. And I want to change the axis to go from pi to 2 pi, just so that I could see the proper values on my screen. There's pi to 2 pi. And I'm going to also graph y equals 5, because remember, we want to know when the, oops, it's supposed to be 5. We want to know when the secant is equal to a height of 5 on this given interval that you see in the screen. And you can see there's only one solution, and it's roughly 4.914. So that would be the answer to that question. This idea of finding intersections of curves using technology should be somewhat familiar to you, but that's just to let you know, on the given interval pi to 2 pi, there's only one solution to secant of x equals 5, and it's 4.914. In the future, we'll have a good analytical way of solving this, which means solving this by hand, and you should already know how to do that via trigonometry, your trig course, but we'll still review that in a future video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.